Today, the lecture I'm going to talk about is advancement of the engineering, geology, and geotechnical engineering. And these two subjects are a little bit similar. I'm not presenting recent research output or or kind of or research paper. Not that kind of. I'm going to present the history of those developments. So most of them are informations, and then may not have a lot of equations and all that kind of thing. My lecture outlined such a way, and then I will initially define the geotechnical prediction. And then I will move on to the describing how this engineering, geology, and geotechnical engineering subject and practice are studied. And then after that, I will move on to some notable developments under the several sub-disciplines such as soil mechanics, foundation engineering, ground engineering, unsaturated soil mechanics, permafrost engineering, waste mechanics, lunar soil mechanics, ground investigation, material testing, computational geotechnics, ground improvement, geotechnical instrumentation, sustainable geotechnics, and environmental geotechnics. So since I got to go through very long list of many sub-disciplines developed within a century, so I will touch briefly on each of them. Then I will show some example of those development and the application in the past century. There's two types of geotechnical practitioner. One is those who took their degree in geology and describe themselves as engineering geologists. Another is those who took their degree in engineering and invariably describes themselves as geotechnical engineers, even when working in the field of geology. There's a considerable extent of overlap between these two disciplines, but these two disciplines are not identical. One describes himself as an engineering geologist, and another describes as geotechnical engineer. But neither cover the whole field. Engineering geology provides geology and geotechnical recommendation, analysis, and design associated with the human development and various types of structure. Geotechnical engineer use discipline of soil and rock mechanics to investigate subsurface conditions and material, determine the relevant physical, mechanical, and chemical properties of these materials. Evaluate and design foundation or infrastructure built on or in the arts or infrastructure built with the arts. As I mentioned, these subjects, some overlapping between these two subjects, engineering, geology, and geotechnology. Geotechnical engineering is the borderland of geology and civil engineering. There's a many overlapping subjects between these two disciplines. Two example overlaps are ground investigations, soil mechanics, rock mechanics, and hydrogeology, or in other words, groundwater hydrology. And then there's a similar type of sub-discipline. These are very similar geological. Why engineering geologists carry out the geological mapping, geotechnical engineer carry out the site reconnaissance survey. And then why engineering geologists carry out material characterization, geotechnical engineer carry out soil and rock characterizations. And then they are also have some similarity in hydrogeochemistry and environmental geotechnics. Engineering geology subjects begin with the very successful service of the warship geologists in the two world wars. Many of the works carried out by engineering geologists for the military roads construction, extensive upwards tunneling, rock cutting for railway alignment during the railway boom and mid-18th century, between 1840 to 1850, were provided by geologists. Earthworks in airfield runway construction in 1940. Remarkable engineering geology service were provided by Rudolf Golosov, who was originally mining engineer, graduated from the Royal School of Mines and Imperial College in London in 1924. Surprisingly, however, there was no single geologist and engineering firm in the industry until 1945. Nowadays, more than 90% of geotechnical engineering services are being provided by engineering geologists, especially in UK and Singapore. If we look at the historical background of geotechnical engineering, it is a young engineering subject developed less than a century ago. And then also the term soil mechanics, this is the basic subject of the geotechnical engineering, was actually mistranslated from the arbor mechanic when our grandfather of geotechnical engineering, Tazali, he first published arbor mechanic in 1925. Actually, it's a mistranslated. And then during the history, there were several times this mistranslation was trying to correct, and then until now it was unable to correct and then stand like soil mechanics. Historically, the origin of the term soil mechanics was due to an error, as I mentioned. The term geotechnology, which is now referred to as geotechnical engineering, was first appear in the lecture given by Golosov in about 80 years ago in 1945 at the Institution of Engineering, UK. But at the time, this terminology was already using in Scandinavia and France and Europe. Nevertheless, much progress have been made during the last few decades. The rate of progress is so fast that it is found difficult for ordinary engineers from the industry to keep pace. A famous textbook we use in the school on soil mechanics, entitled Soil Mechanics and Engineering Practice, was first published in 1948 by Tazagi and Refbeck. A letter written to Golosov by Tazagi on December 17. This is only just 14 years after this book was published. At the time, he was revising that textbook to a second edition. So he wrote this phrase: the sale record showed that the book is still going as strong as ever, in spite of the fact that several parts are very much out of date. Just a matter of within 14 years, the subject matter becomes out of date. Other notable developments are: first engineering geology textbook was published much earlier than the soil mechanics by William Penny in 18th century, late 18th century. First soil mechanics textbook only published in 1925, as I mentioned. First international conference in soil mechanics and geotechnical engineering was held in 1936 at the Harvard University in United States. First soil mechanics laboratory was established by BRE in UK in 1933, about 90 years ago. First specialist geotechnical firm called Soil Mechanics Limited was established by Golosov in 1944, about 80 years ago, and they are still operating in UK, doing a lot of ground investigation works, laboratory works, and all that. The early definition of engineering geologists was only started using in 1951 that is only 70 years ago only by Executive Committee of Engineering Geology of Geological Society of America. The Geological Society of London established engineering group in 1964, about 60 years ago. Soil mechanics. Very first soil mechanics theory was developed by the French Gardener named called Charles Coulomb in late 17th century, 1773. His theory was updated by taking into consideration of the soil structure interaction by the Scott academic William Rankine in 1852, about 18 years later. So after that, although they developed this Coulomb's theory in 1776, Bauban published empirical table of the earth pressure in as early as the late 16th century, 1619. Grouting and method and process were developed by engineering geologists in 1815. Rankine gave theory of earth pressure lecture in 1857. Graphic representation of the state of the stress by Moore in 1871. Boson's theory of stress distribution in 1885. Concept of consistency limit by Swedish scientists called Edebach in 1911, and varying capacity theory was first developed by Fredel in 1920. As I mentioned, soil mechanics theory began with the arbor mechanic, translated into the English words as soil mechanics, based on the consolidation test carried out on the thin layer of the compressible soil during early 1920. After he proposed the consolidation theory, there is another alternative theory proposed by his colleague from Austria Technological University called Professor Villinger's consolidation theory. Professor Villinger not only proposed the alternative consolidation theory, he also accused Tazagi of overlooking very important aspect of the hydrodynamic behavior of the consolidation process. So Tazagi, he felt insulted, and then he complained that matter to the university rector. So since consolidation theory was very complex, the university rector approached international academic community to assist in making a judgment on these two theories. So academic board consisting of 5 academics, some of them from USA, some of them from UK, reviewed these two theories. One day before the decision from the academic board came out, the rumors came out as academic board supported Tazagi theory. By hearing that rumors, Professor Villinger and his wife suicided on that night. The next day, one decision came out. That decision was academic board accepted both theories are correct based on their own assumption. However, the potential talented one of the geotechnical pioneer professor, life has been lost. So how complex is that this first soil mechanics theory of consolidation? Because of that, potential geotechnical pioneer life and his wife life was lost. After that, consolidation theory advanced and developed by combined theory of the vertical and radial flow by Carrillo in 1942 and Baron in 1948. Three-dimensional consolidation theory by Byron in 1955. Glass strain consolidation theory developed by Gibson and Lowe in 1961. Existence of tertiary compression by Chandler and Chatri in 1988. Also, soil strength theory, but notable developments are pore pressure parameter by Scampton 1954, understanding of the matrix section and unsaturated soil mechanics by Lighton in 1967 and Fredland and Rahajo in 1993. Development of the critical state soil mechanics based on the mechanical properties of the saturated removed soil by Scroffy and Watt in 1968 and Atkinson and Brunsby in 1978. Findings on stress strain dependence behavior of soil by Leroy in 1985. Why soil mechanics theory was developing during the last few decades, there was a very important theory called bearing capacity theory. When the geotechnical engineers began his career, the first thing they need to step under the training was calculating the bearing capacity. So that bearing capacity equation was first developed by Pradel in 1920 before soil mechanics subject was developed. Kazaki in 1943 modified the equation slightly to use and design of bearing capacity of the foundation based on shear strength of the soil by taking into consideration of shape factor with the position and base time. Since from then, many developments were made by taking into consideration of depth and inclination factor by Meyerhoff in 1951 and 63, ground inclination factor and base inclination factor by Hessen 1970 and basic 1973 and 74. Mardilia soil condition by Burton in 1953. Before the soil mechanics subject and also the bearing capacity theory was come out, our great-great-grandfather, they successfully managed to build a very heavy and huge structures, even on the poor ground, without the use of the bearing capacity theory. So those are examples, those are pyramid in Egypt built on the loose granular soil, and then pyramid in Mexico built on the compressible soft soil, and then many pagodas in Myanmar built on both loose granular soil and compressible cohesive soil. Why they managed to build successfully, if you look at it, their structure, most of the structures, their base are very big, and then they use a manual levers to build these structures. When they use a manual lever, it takes very long to raise the level. So because of that, during the construction, consolidation process occur, and then soil strength happens. Because of that, they managed to build stage by stage to build to the very high top level. In addition to that, their center of eccentricity is always within the base because bases are very big. But when they build a slim and tall structure, what happened? Tower of Pisa. It was started building in 1173 AD with a basement of 1.5 meter deep. Completed 3-story. About 5 years later, stopped due to the politics and death. But at the time, tower already tilted to the south. And then only nearly 100 years time, they restarted with the compensated weight at the north to counter at the tilt. And then 6 years later, they completed 7-story up to here. At the time, tower tilted to the south by 1 degree. And then another nearly 80 years time, constructed this top chamber, bell chamber with the compensated weight on the north by adding more steps in 1360. This 200 feet high tower with weight of about 1,445 tons was completed and officially opened in 1317. So very slim and tall tower, built on the soft clay. In 1990, the degree of tilt reached 5.5 degree and predicted to be fallen by 2050. So this is about 30 years time from here now. Therefore, they placed counterweight of 600 tons in 1993. Also attempt to stabilize by ground freezing methods, but the lean was increased. And then therefore, in the same year, in 1995, they put additional counterweight of 870 tons to stop the concrete leaning. Only in 1999, with the development of the ground engineering technology, applying the ground engineering technology, they use the soil extraction methods by drilling the inclined hole down to the underneath of the footing, and then extracted the soil from underneath the footing. By extracting the soil, the voids occur. So when the void is closed, the tower lean back to the south. So they drill many inclined holes underneath the south side of the footing. This is a drilling of the inclined hole down to the underneath of the footing. This is a compressible layer they already settled. Because of that, settlement is greater on this side, so it tilted to this side. So using this method, the tower was successfully made to lean back towards the center by 0.5 meter, which is the same degree of lean as 1838. So tower will be safe for another maybe 2 centuries possible. This is a rotation measure during the soil extraction. This is a settlement measure during the soil extraction. You can see the settlement generated at the north side by soil extraction. This is the south side. So by applying the ground engineering technology, we managed to save the valuable heritage structures. There's other theoretical developments such as unsaturated soil mechanics, soil structure interaction, permafrost engineering, freeze and thaw or soil and thaw consolidations in the core region. Frost heap occurrence because of all the rock in the core region. They heap up, frost checking, check up the foundation, and then also bearing capacity for the winter ice flow. This is not the soil mechanics. This is the ice mechanics. Using the ice mechanics, manage to analyze the bearing capacity. Geotechnical engineer not only study the ice mechanics, they also study the waste mechanics. Soil mechanics is very complex because of there are three-phase soil measures consisting of the solids, whites, water, and all that. And then waste mechanics is more complex because they have 4 phases. And then for this waste mass, they differentiate it into the inter and intra-wide. So intra-wide is a kind of like bottle, cans, and all that. They can immediately compress after putting it low. In the consolidation theory, there's a primary consolidation, secondary compression, and then also nowadays people are talking about the tertiary compression as a third phase of the consolidation process. And soil voice mechanics it is another phase which generate the settlement is a settlement due to the biodegradations. So we have been dealing with the pore pressure in the soil, this complex nature of the process. And the waste mechanics is more complex. They have a gas pressure there. And the cut in 1995 has a very good book on the dealing with the gas pressure. Geotechnical engineer not only cover the ice mechanics, waste mechanics, raw mechanics, they also cover the lunar soil mechanics. Compressibility of the lunar soil, applying large strain theory by Carrier 3 in 1968 is a very famous theory. And the Geotechnic Journal published a paper on the lunar soil in as early as 1948. This is only about 5 years after the first soil mechanics book came out. This paper was published by William in 2011, and William stated that in 2011. Dr. David Carrier, he received his bachelor, master, and all the way to doctorate degree in civil engineering from the Massachusetts Institute of Technology. After the graduation, he joined NASA in Houston in 1968. Specializing in lunar soil mechanics. A few months before the flight of the Apollo 11, he briefed Neil Armstrong and Buzz Aldrin on how deep they would sink in the lunar surface. He predicted applying the large strain theory he developed. He also predicted how much landing ship will be sunk into the moon surface by predicting using the large strain theory. During the history, the ground investigation, which is a very important phase of the geotechnical project, in the ground investigation, especially in situ testing, many developments were made, started with the standard penetration test, P-vane shear test, in situ hydraulic conductivity test, dynamic cone test, cone penetrometer with pore pressure measurements, dilatometer, pressure meter, surface geophysical survey, borehole geophysical loggings are some of them, but this is not exhaustive. This is a standard penetration test and the ground investigation carried out in foreshore area using the Jacob Pondy. Some ground investigation carried out on the offshore area using the site investigation ships. This is a SPD hammer dropping to carry out the SPD test. Fever shear test usually used to measure the strength of the soil using these plates. And then they need to follow the standards, waiting time, rotation rates, and all that to obtain the more accurate results. This is a video showing some fever shear tests being carried out in the borehole. And then they rotated the blades. There's many types of CBD mounted onto the different transportation equipment, mobilization equipment like this. Some are on the car and then some are on the crawler. CBD are also used in the marine conditions, and then they can drop from the ship and then sit onto the seabed and then penetrate it. So these CBD measure foam resistance and friction value. From there, they can classify the type of the soil, and then they can correlate to the strengths, over consideration ratio, etc. Likewise, Professor Marchetti also developed the dilatometer, and then dilatometer also inserted into the ground like CBD equipment, and then when they reach to the required level to test, there is a membrane there at the one side of the blade, and then expanded that membrane to push with the static forces, and then from there they obtain the dilatometer parameter, and then these parameters can be correlated to the undrained shear strength, modulus, K0, over consideration ratio, etc. Also, they can carry out the dissipation test, and then from there they can determine coefficient of consolidations due to this is a dilatometer test being carried out. There's a few types of pressure meter, such as started with the Myint pressure meter, and then also they have a set-boring pressure meter, and then also they combine CBD with the pressure meter called cone pressure meters. So basically, these pressure meter body is inserted into the ground at the required test location. They expanded this membrane cylinder into the ground, and then they measure the stress strain characteristic of the soil. They can do the also unload, reload, loops, and all that. From there, they can obtain the many parameters like undrained shear strength, over consideration ratio, modulus, etc. When will be the time ground investigation constructor be running out of work, because every day 2,000 of the geotechnical rules are being carried out around the world, but there will be no time investigation work will be running out. Even the astronauts, before going to the space exploration, they got to go the soil investigation training. This is one of the astronauts using the handheld push and sampler to collect the sample. And this sampler is mini type of the SPD sampler, but using the static forces, you push it down, and then sample can be collected and then brought back to the earth. And this is a glossy orange lunar soil under the microscope. And then another astronaut using the handheld cone penetrometer equipment, and then measure the resistance of the home resistance of the lunar soil. Dr. Harrison Smith was the first geologist on the moon, and then later he became a senator of the United States. About 20 years ago, using the geological investigation methods for remote sensing, using that, they managed to detect the neutron flux on the north and south pole of the moon. So neutron flux is indicating the existence of the water. I think you may know all the nuclear gates measuring the moisture contents. They have the neutron elements there, and then neutron elements can detect the hydrogen and oxygen ion. So by knowing that, NASA developed the ground investigation program. And then they sent the 2 rockets to the moon, targeting to strike that crater where the water is expected to be found. So 2 rockets were sent to the moon, and the first rocket hit the crater. So when they hit the crater, the plume of the moisture developed. So that moisture exposed to the solar energy, ultraviolet energy, sublimation occurred. Because of that, hydroxide production was happened. And then this plume of the hydroxide exposure was generated. These features was taken and recorded by the second rocket followed behind the first rocket, and then managed to confirm the existence of water on the moon. This is a very important and prestigious finding of the water on the moon, which is important for the settlement of the human being. So ground investigation was not only carried out on our Earth, also carried out on the moon, and then recently, not very long ago, there's a CPT equipment and all that they sent to the Mars, and the ground investigation was carried out on Mars as well. On the experimental laboratory test methods, earlier we have been using the 24-hour consolidation test for the 1 step of the consolidations. And then the geotechnical engineer realized this 24-hour loadings consists of the secondary compression. So in order to eliminate that step, primary consolidation tests were developed. And then knowing consolidations behavior is a stress-strain dependent. So consider your loading tests, consider your strain tests were developed, and then also to consider the hydraulic gradients, also they develop the constant gradient test. And then consolidation process nowadays not only rely on the vertical flow, they also rely on the radial drainage, especially on the soil improvement methods using the prefabricated vertical drain. So they also develop the Roser test, which can carry out the consolidation test with the side central and both drain. On the strength test part, in the very old days, people used to carry out the unconsolidated and confined compression test to determine the material. Nowadays, they carrying out that test on the very strong soil and concrete like that. But however, soil in situ are confined under the stress of the soil surrounding. So because of that, this UC test may not be representative of the in situ condition. That's why they developed the and consolidated and drain test, but they are confined under the isotropic water pressure. So they are confined under the isotropic. However, in situ soils are not unconsolidated. They are consolidated under the at least overbearing pressure. So some of them are even over-consolidated due to the past history. So that's why geotechnical engineer developed the isotropically consolidated and drain test. But when you really think about that, soils are not consolidated under the isotropic condition. Isotropic condition is a particle stress and horizontal stress are same, but in situ they are not the same. They are horizontal stress are multiplier of the K naught with the relationships to the particle stress. That's why K naught consolidated and drain tests were developed. There are some other strength tests, stress pad tests, strain pad tests developed by Bishop and Wesley in 1975. Stress history and normalized soil engineering properties. Famous development of the sham set test by Led and Fu in 1974. Some development of the direct shear stress. And then in many times during the loading, stress rotations are occur. To model this condition follows standard test development. There's many other tests were also developed during the last two decades. In the computational geotechnics subdisciplines, there's a development in slope stability using the liquid equilibrium methods, post-liquid equilibrium, moment equilibrium, and strength equilibrium for 5C reduction methods. And then there's some limit state analysis, and then we started, developing the limit state analysis because nowadays ultimate bearing capacity is no longer important because you are living in the, well-developed urbanized country. So people may not, allow your success to be defined until the ultimate conditions. So there will be some limit state required because your neighbor may not want to set his house footing, less than 1 millimeter. They can specify it. So limit state analysis where develop ultimate limit state, substantially limit state. Among this limit state methods, two famous methods are European methods for strength factor methods and North American methods for load factor methods. Two famous tunneling methods for Norwegian methods of tunneling and New Australian methods of tunneling. And then finite element modeling for the stress deformation analysis were also developed in last few decades ago. That had been design of the earth and infrastructures on the ground more accurately. If we look at the finite element modeling, the stress deformation analysis was impossible to carry out until maybe 3-4 decades ago. They are now indeed possible due to the development of the finite element model. In 1967, Whitman and Bailey presented how an engineer in the future using keyboard and monitor to perform geotechnical analysis quickly and efficiently in the first international conference on stability and performance of slopes and embankment. Duncan in 1996 stated in his State of the Art lecture, quote, when Whitman and Bailey presented their paper, the scenario this described was in large part considered as a science fiction. Even people are difficult to accept it. They thought it is a fiction, unquote. Subsequently, after that conference in 1967, the final elements method was introduced to geotechnical engineering professional by Cloud and Williams. First commercial FEM software was launched in late 90s by Chris for the geotechnical engineer. Currently, there's 5 main players like LED, Physics, Sigma, W, Abacus, Soil Vision, etc. Some of them merged together as a family, the Physics and Soil Vision. With the long history of the human development, human population increased to the more than 5-6 billion, and then all the cities developed in few centuries, of course, are now very congested and then thickly populated. If you look at it in all the old cities, most of them are constructed at the river mouth or on the seaside. The reason they try to develop there is that they have a transportation assessment to the oversea through the sea and then inland through the river. So unfortunately, those river mouths have normally soft deposit of the compressible soil. Soft deposit of the compressible soil. Because of that, good ground locations becomes rare and rare. So the geotechnical engineer has to look for the ground improvement method to improve the ground by many ground improvement methods. The preloading and vertical drains are famous ground improvement methods extensively used in the Changi land reclamation project in Singapore, and then to certain extent in land reclamation project in Kansai International Airport in Japan, as well as in Chiklakau Airport in Hong Kong. These land reclamation deposited granular soil loosely, and then they are prone to the liquefaction, and then they also generate the immediate sediment. In order to eliminate these thickly deposited claim land has to be compacted using the decompression methods called vibroflotation, dynamic compressions, and resonance compression, etc. Geotechnical instrumentations and observational methods. All types of material in the universe are deformable. Deformation can be either linear or non-linear. It is recoverable or non-recoverable. Soil deformation is a complex electroviscoelastic behavior. So in addition, additional stress imposed on the soils varies in magnitude and directions, also varies in rate of the loading. Therefore, predictions are rarely the same with the performance. So in order to fine-tune, geotechnical engineer develop the observation methods. For that, geotechnical instrumentations like piezometers, sediment gauges, and inclinometer, up pressure, etc. were developed. Professor Redpack is a co-worker of our grandfather of soil mechanics, Dazagi. He published the first book together. When Apollo was about to launch, this heavy and tall equipment, equivalent to 35 stories of the tower, was required to transport to the launching pads on the crawler in the vertical position. Unfortunately, that launching pad was connected to the land by the causeway. And unfortunately, this causeway was underlain by the very loose deposit of the silt, which is a SPT group or 0 to 1, very loose. By passing this heavy equipment with the static load and dynamic forces, this causeway could be collapsed. If it is collapsed, this multi-billion-dollar worth of this rocket was lost. Not only that, the space exploration program is very tight and very important for the political aspect. So this space launching exploration program will have to be postponed. Many methods were considered, like fiber flotation, stone column, etc. But these methods take a bit longer than could be longer than expected. So space program has to be postponed. So they cannot allow this to happen. So Professor Redback, taking the challenge of this issue, and then he offer his service to transport this rocket to the launching pads by applying the observation methods. What he did is he installed piezometer in the silt deposits. And then he take control of the driver of the disc crawler. And then ask them to drive until very close to the critical bore pressure. And then when that observations monitoring show about to reach the critical bore pressure, the driver was asked to stop. And then until bore pressure dissipates to the acceptable level. And then ask them to drive again, and then stop, drive, stop, and all that. With this repeated process, this spaceship was managed to transport to the launching pad, and then space program was implemented successfully without delay by using the observation methods. This is this one-step bore pressure dissipation. In old days, monitoring of instruments were carried out manually using the total station and study raw etc. using the survey methods. Nowadays, development of the electronic geotechnical instrument, geotechnical engineers' life become much easier, and then they can connect those via to the office and then monitor from the outside office. With the development of the telecommunications system and solar panel, nowadays using the electronic geotechnical instrument, you can capture all the monitoring data and then transmit through the modem, and then you can receive the data anywhere around the world while you are traveling or you are at home. Geotechnical engineer, as I mentioned, not only study soil mechanics, and then they also study waste mechanics, and then they are helping to contain the contaminated waste in order to not to migrate to the groundwater resources. So many landfill methods containing the waste within the pan and then cover with the suitable cover material to minimize the infiltrations. Also, geotechnical engineer involved in the containing the nuclear waste. And then waste mechanics, as I mentioned to you, they are more complex than the soil, which is a three-phase. Waste mechanics as a four phases, intervoid and intervoids. Geotechnical engineer involved in the remediation of the contaminated land. Geotechnical engineers study the environmental geotechnics, and the engineering geologists study the hydrogeochemistry. This is one of the research projects we carry out in the Western University in Canada. What we did is that we carry out the research on application of the biotechnology together with the electrokinetic to do the remediation work for the contaminated land. We breed the bacteria, which is the diesel moss, and then we DNA coded each bacteria, and then look for the bacteria which can eat the diesel moss, and then they have a comparatively longer life. And then not only we look for the bacteria, which can eat the diesel, because their life are short, and then their migration ability to migrate is a very slow and then also limited distance. So transported this bacteria, applying the electroosmosis flow from the cathode to anodes, so that they can travel longer distance with the faster speed. Not only that, we also transport the nutrition behind so that they can eat their nutrition to extend their life. So this process was experimented in the laboratory, and then after that we moved to the small scale feed-test, and then both of them were successful, and then I think there's some paper published in environmental geotechnics, and then now planning for the large scale actual feed-test. In the sustainable point of view, geotechnical engineers were involved. Once sustainability was first appears in 1972 in the context of men's futures in the book named Blueprint for Survival by Goldsmith in 1972, outlining the need for serious economics and environmental changes. Sustainable development as a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. In order to save the natural resources, geotechnical engineers have been exploring and reusing of alternative materials such as various types of waste in the construction industry, like the fly ash, steel slag, demolition waste, pavement constructed with the glass wave, tire bay for environment, shredded tire for filter, biosolid in the environment construction, dredge soil using the dredge material, and then reusing of the old foundation. Coincidentally, I think this month there is a special issue for the sustainable geotechnics. We and two others professors editors will come out from under the environmental geotechnics journal from ICE. Geotechnical engineer also help in the global climate change. Yeah. Geotechnical engineer not only design the foundations for the safe foundation design, safe ground improvement design, not only for safety, but also for the economic design. Nowadays, geotechnical engineer has to design the process or infrastructures which minimize the carbon emission. So we got to do the comparative study, which methods induce that it emits the less carbon dioxide. So to save the world to control the global climate change. Also, geotechnical engineer involved in the carbon capturing. Geotechnical engineers are actively involved in the redesign of the soil protection structures to prevent the water level rise, sea level rise due to the global climate change. This process has been studied since more than 2 decades ago. I was heavily involved in the law heavy flood prevention structures in the United Kingdom. This was carried out in the early 2000s. Geotechnical engineer also involved in the health outbreak when about 2 decades ago, when foot and mouth disease occur, and the geotechnical engineer has to look for the suitable ground location to dispose of that dead animal, to contain the contaminants, leachate. And then also geotechnical engineer has to look for the suitable cover material to prevent the, to minimize the infiltrations. And then geotechnical engineer has to install a lot of monitoring well at upstream, downstream, and all that to monitor the migrations of the dead pollutants, leachates, to prevent not to enter into the aquifer, which are using for the drinking water. When H1N1 outbreak occurred, also the same process was implemented. When this COVID-19 pandemics occur, the technical engineer has to come up with the mask varying design and all that to prevent the migrations of the COVID-19 contaminated substances, and also the mask varying for that human dead body. In old days, most of the cemeteries are usually built on the area which is underlain by the massive floor, and then they have a slope on the slope to minimize the infiltration. But in many countries and many cities, they are on the flat ground. They don't have such kind of features to benefit for the accelerate and improve runoff and minimize infiltrations. Example of which is the Oklahoma City. People from the Oklahoma, they use the drinking water from the groundwater aquifer, and then their water, they felt sweeter than the water imported from the other states. And then they found their groundwater was contaminated with the protein. That protein was leached from the decomposed body from the cement. So they got to do some remediation works and then isolating this cemetery with the particle barrier, etc. London is a very highly populated since from the 18th century. They have nearly 10 million people, and then very long history of the urbanization. They has many cemeteries. Nowadays, because of the increased population for very long period and then very thickly populated, they run out of the cemetery site for the cemetery. So I think maybe about nearly 7 or 8 years ago, London City, they changed the bylaw. We use the cemetery, and then we use that grave location. So with this, what they are going to do is that they are digging the old grave to the deeper level, and then put the old one at the bottom, and the new one will come on the top, and then they will use the cemetery. And then for that, they will put on the tombstone in front will be the old one, and the back one will be the one. For that, they got to do a lot of ground investigations because they are digging the old grave, all that. So ground investigation, extensive ground investigation might have very. Geotechnical engineering has been applied not only in the construction, but also in the rescuing valuable heritage structures, like Pisa Tower, exploring new land for human beings, exploring to the moon, Mars, and all that, transportation being the heavy equipment. And then we also involve in protecting the environment we are living in. Geotechnical engineer and engineering geologists are continue developing these two subjects with the many developments during the last couple of years. Thank you very much for your attention.